Okay, mathematicians. Looking at a Unit 4, which was what I used last year to practice the concepts of derivatives and apply them with many things that derivatives can cause us to do. So you pretty much have the whole unit here that had all lecture notes that I would go through. And there's also homework after each lesson. But what I'm going to do, so let's drop in on this free response problem. It's labeled as 2008, and it was a Form B problem. Back in those days, there was 2 sets of free response problems. Good review. Got an implicit function. Very typical. See the x's and y's embedded into the equation. And the answer for A is given for you, that the derivative of y is this answer. So we just have to show that it's true. In other words, I want to know if you know how to do it. So from left to right, 2x has a derivative of 2. dx because we're differentiating with respect to x. So dx is a 1. So I don't have to do anything with that x. Just do the derivative like normal of x squared, 2x. Sorry, I lost the x. dx. Now plus, when I do the y, remember, it's going to be 2. Well, it's still a 2x. I'm sorry, there's my 2. When I do the y, it is 4y cubed. But I always have to end it with dy dx because the derivative with respect to x of y is dy dx, whereas the derivative with respect to x of x just cancels out. So we tend not to put that there. But the y's I have to. That's what I'm solving for anyway. Then I have a 4y, so it's just going to be a plus of 4, but don't forget, we were doing the derivative with respect to x of y, so it's dy dx. And the derivative constant was 0. So we have 2 dy dx's, and I'm going to factor out this and this piece out of the dy's. So I'm going to rewrite those as, if I pull out the dy dx, that still left a 4y cubed plus a 4. And these two terms, I'm just going to move them to the other side because they're not helping me with the derivative on the left side. So that just becomes a negative 2x minus 2. There's only one step left. Divide both sides by 4y cubed plus 4. And that cancels. So my derivative that I have is equal to negative 2x minus 2 over 4y squared plus 4. Now, is that what he has here? It's not what he has here. It looks somewhat similar, but it's because that is the answer. But you go further and say factor out the negative 2. That gives you an x plus a 1. Factor out the 4. That gives you a y squared plus 1. And the 2 goes into the 4 twice, and the negative stays there. Negative x plus 1 over a 2y squared plus 1. And does that look better? Let's see. Does that look better? Yeah, that looks a lot better. So I'll go, yep, it's good. I verified it. Now B. Let's find the coordinate of the 2 points on the curve. He says there's 2, where the line tangent to the curve is vertical. Now you need to remember that a vertical tangent occurs, I'm going to give a little note, vertical tangent occurs where dy dx is undefined. So that means, I'll make another note, the denominator is 0. Denominator, bad handwriting. Denominator is 0. So what I'm going to do is I'm going to take that denominator, the 2 times the y plus 1, and I'm going to set that equal to 0. 2 times y plus 1. If that was equal to 0, which it can't, or it's undefined, that's the whole point of a vertical tangent, Solve that for y, and let's see what we get here. What do I get here? I am doing the right one, right? Write the equation of 2 points on the curve where the line tangent to the curve is vertical. Okay, so I get y plus 1 is equal to still 0. Y is equal to a negative 1. So y is a negative 1. So I need 2 coordinates. That means I got to take that y and I have to plug it into this function here to see what the x value is. So I'm going to write that out. I'm going to x squared plus 2x plus y to the fourth plus 4y equals 5. Let me write that out. Y to the fourth, right? Yeah, because it matched up with the 4y. Okay, so if y is a negative 1, that gives me x squared plus 2x negative 1, negative 4 equals 5. Oh, it's a quadratic. X squared plus 2x minus 5, and then another minus 5, that's minus 10 equal to 0. That's how you solve a quadratic, get everything on one side. And that factors, I hope it easily factors, an x and an x. And then well, 5 and a 2 doesn't add up. Of the 2 point with a line tangent vertical. Where did I go wrong? Denominator was, it's supposed to be 4y cubed. That'll do it. 4y cubed, that should be a cubed. Let's see how that changes my denominator. 2y cubed plus 1. 2y cubed. I didn't even put the square there. That was, all right, so that just means you just saw me do a blunder. Hey, it's not the first time. Now, if I had you in front of me, somebody would have stopped me maybe. Okay, let me just finish it. So y cubed plus 1 equals, it's not a quadratic. Y cubed equals negative 1. And taking the cube root of both sides, cube root, y is a 1. Negative 1, sorry, because negative 1 times negative 1 times negative 1 is still negative 1. So therefore, there's my y. So using the equation that was the original curve for x squared, it was plus 2x, then it was a plus y to the fourth, wasn't it? And there was still a 4 that matched up, I remember. And the constant was, I forgot, 5. Okay, so if y is a negative 1, what do I get? I get x squared, because there's nothing there, plus the 2x, there's no y there. But when I fourth root a negative 1, that comes out to a 1. And then when I have my minus 4 comes down, 4, well, it's 4 times the negative 1, it's going to give me a minus 4 come down. That was supposed to be a 4y. I don't know why I didn't write the y. Okay, e equals to 5. And 1 minus 4 is a negative 3. I'm going to subtract negative 5, put it all on one side. X squared plus 2x minus 8 will be 0. Let's see if it factors. X and x, factors of 8 are 4 and a 2. I need a positive answer, so it's positive 4 gets the big one. Minus 2 equals to 0. X can be a negative 4, x can be a 2. So my ordered pairs are going to be negative 4, negative 1, and 2, -1. And did I answer the question? I did oh, I just did C. All right, this is C. Got ahead of myself. Hey, I'm almost done. No, it was C. I never did B. So let me go over here. Well, I'll go down. It doesn't really matter where I put it. B. B was asking me for write an equation for the line tangent to the curve at -2, 1. Okay, so I want the equation of the tangent line at the ordered pair -2, 1. So I need the slope of the tangent line and I need the point of tangency. So this gives me my slope, this gives me my y1. In the equation, y minus y1 equals the slope times x minus x1. And obviously x1 comes from this x right here. So where am I get the slope from? Well, they gave you the slope formula in the original problem. Plus, we proved it. And they gave it as a negative of an x plus the 1. And we did prove it. It was over 2y cubed plus the 1 as well. So at -2, 1, that's going to give me the slope is negative of a -2 plus 1 over a 2 times a 1 cubed. 1 cubed is 1 plus the 1. So the slope of the tangent line will be -2 plus 1 is a -1. -1 times the negative is a 1. And a 1 plus 1 is 2, and 2 times 2 is 4. So I think the slope is 1/4. And the point of tangent C, which is y1, will be equal to y, I guess I don't know, call it y. I'm going to say y1 will be what happens when the function, when x equals to, well, we know what the point is. We know x is equal to -2 and y is equal to a 1. So I got to plug those into that equation. The same equation that I just used over here. It was x squared plus 2x plus 4y to the 4th plus 4y equals to 5. So we got to make sure that we just plug in at the -2, 1. So the fun begins. This will give me my point of tangency. Why am I doing all this work? That's silly. We already know that this is going to be a true statement. That was silly. I don't know why I get on a tangent. I don't need all that. Got to keep it simple. All right, we already know the point. Silly. So I can go and use my equation right here and say y minus y1, that's a 1, I believe. Don't you think? Anybody? I think so. And the slope, we did use that calculation. We did get the 1/4. And the x value is the -2. I'll bet you any money that x minus -2, that's supposed to, I bet you any money somebody out there was yelling at me and say, why are you doing that work? And you can leave this as your answer. There's no reason to solve for y. You guys are always solving for y. You don't have to on the AP test. Just leave it, because you're probably going to make a mistake anyway. All right, very good. It was A, B, and C. Okay, D. Is it possible for the curve to have a horizontal tangent at points where it intersects the x-axis? Explain your reasoning. Well, D D. He's asking me, can I have a horizontal tangent? Well, first of all, what's horizontal tangent mean? It means that your numerator is equal to 0 of my derivative. And what was my derivative? My derivative was, I got it written right here, negative x plus 1 over the denominator. All I need is this part right here. So I'm going to say negative times x plus 1 is equal to 0. That gives me x plus 1 is still 0. X equals a negative 1. If I plug that in to my well, what do I need here? If x is a negative 1, what is y going to be at that value? Read the problem again. He says, I want the horizontal tangent where it intersects the x-axis. That means y is 0. Too much moving. If I intersect the x-axis, the y is 0. So I know it's going to be 0. So I take my equation, and I've written it down 100 times now, x squared plus 2x plus y to the 4th plus 4y equals to 5. He's asking if it's possible. So let's see what happens when I plug in this ordered pair, 1, comma 0. Let's see what happens. I get a 1 plus a 2. Wait, no, wait. Is it a plus a 2? I'm sorry, it's not a 1. X is a negative 1. Come on, Cartwright. All right, negative 1 squared. I'll write it out. Negative 1 squared plus 2 times negative. If I don't write it down, I'll mess up. Negative 1 to the 4th. No. Y is a 0. Plus 4 times 0. Is that possible? That's what we're asking. 1 minus 2 plus 0 plus 0, is it 5? Negative 1 is 5. And negative 1 does not equal to 5, so that you cannot have the horizontal. You have to write it out then. It is not possible to have horizontal tangents that cross where the curve intersects the x-axis, right? That horizontal tangents that the curve, or at the curve, at where the curve, you write it better, curve intersects the x-axis. Well, because when x equals to negative 1, y would have to be 0. Well, basically, 1, 0 was not on the function. 1, 0 is not on the curve. All right, it's a good, very good free response problem. Very good free response. A lot of work, though. How long did it take me with all my gibberish? 18 minutes? You'd have gotten 15, okay? So you wouldn't have done all the extra talking. All right, let's see what else would I do. Down to, let's do another one. Do another one here. What's the same thing? It's another free response that does the implicit, so I won't do that one. You should do it. You can always look it up. Do I want to do this problem? Yeah, I'm gonna skip around and do some AP problems. And so again, this is 215, number 6, and there's 3 parts. Well, Okay, this involves second derivative, so let's do it. Consider this implicit function. Consider that we already know the derivative right here. Good, good, good. A says, write the equation of the tangent line for the curve at that point. So we need a slope of tangency, which is my m. Well, there it is. And he gave me a point at this ordered pair. So if dy dx is equal to a negative y, we'll write that out. It does say negative, doesn't it? No, it doesn't. Y over 3y squared minus x, and d at the point negative 1, 1 of dy, I'll just put dy dx. I should just say that, dy dx, instead of making it complicated. I'll just write the words out. At negative 1, 1, the slope is, okay, the y is a 1 over 3 times 1 squared minus the x, which is a negative 1, minus a negative 1. Hopefully you realize that's a plus. That's 1 over 3 plus 1, 1 over 4. Okay, so then I already have the ordered pair. I'm not going to play any games. I have, this is y1, okay? And x minus x1. This is x1, so y minus y1, that's y minus 1, will equal to 1/4 times x minus minus 1, x plus 1. There is your tangent line. Just leave it. Don't work too hard. B, time I will not skip a spot. Find the coordinates of all points in the curve where the tangent line of the curve is vertical. We're doing the same thing. Vertical, say it to the reader. Vertical tangents occur when dy dx is undefined, or in other words, the denominator equals 0. So I go back up to my derivative, and where did I write it at? I didn't, I circled it. It is y over 3y squared minus x. Yeah, y over 3 is minus x. Oh, I have it right there too. So I'm going to go 3y squared minus x has to be equal to 0. And the equation of that, it's going to be a lot of points, so you may as well just solve it for one of those variables. And it's going to be harder to solve for y, so I'll solve for x. 3y squared will equal to x. So I'm going to use that into the original function to find the relationships I can solve for y. So if the original function was y cubed minus xy equals to 2, write that out. Y cubed, do another color, y cubed minus xy is a 2. And I already solved it for x, so it's going to be very easy to solve for y. Y cubed minus 3y squared times the y has to be 2. So you see, you've created an equation which only y is in it. Y cubed minus 3y cubed I believe that's what it gives me, equals to 2, which is negative 2y cubed equals to 2, which is y cubed equals to 2, negative 2. So I can take the cube root of both sides. Y equals 2. Now, the cube root of a negative is still negative. Cube root of 2. And it's not... Did I do it right? Oh, no, wait. I didn't divide right. 2 divided by negative 2 is a negative 1. Hello? Okay, so cube root of a negative 1 is negative 1. So there's your y's. So we have our x's. Well, we don't have the x yet. We've got to now take this answer, plug it into what x always is based on the y. So if 3y squared was equal to x, and y equals to a negative 1, then wouldn't that give me x equals to 3? So there's only that one point. 3, comma, negative 1 is the only point where we have a vertical tangent line. C. Okay, back up to C. Evaluate the second derivative on the point of the curve where x equals negative 1 and y equals to 1. Okay, so we want the second derivative, dy dx at, the ordered pair was negative 1, 1. So we have the derivative. It was actually given in the problem up there. It was actually given up there. So we're going to use that derivative. Okay, we're going to use that derivative. Let me say it to myself here as I remember it. Was a y over 3y squared minus x. I'm going to call it y prime just to be easy. Y prime is a y over 3y squared minus x. So the second derivative will be, it's going to have to use quotient rule. So the bottom, 3y squared minus x times the derivative of the top, which is y prime. And then it's minus the top, which is y, times the derivative of the bottom, left to right, 6y dy dx. Oh, wait, why am I switching it? I was doing y prime to keep it easy. 6y y prime minus 1. So there's the derivative of the bottom, the bottom times the derivative of the top, minus the top times the derivative of the bottom. Oh, I still got to divide all that by 3y squared minus x, and I got to square that. So let's simplify. I think it's just a lot of algebra. It's just not going to be very pretty at all. But maybe I don't need to simplify it because he wants the derivative at negative 1, 1. I can do second derivative at negative 1, 1 right now is 3 times the 1 squared minus the x, which is a negative 1, becomes a plus 1, times the derivative at that same point. I'll remind you what y prime was. Y prime, well, there it's right here. That was y prime. I got to plug my ordered pair into that derivative as well. So that's going to be the y, which was a 1, over 3 times 1 squared is still a 3, minus the x. That's going to give me a minus 1 plus 1. Okay, that wasn't, I didn't write. Minus the y again is a 1, so I don't write nothing. 6 times y is 6 times 1 times the derivative at 1. You know, the derivative at 1, it's the derivative at 1. I already calculated that. I should do that. what was I prime at 1 comma negative 1? It'd be so much easier because I'm going to use it a couple times. That was a 1 over a 3 plus 1. It's always a 1/4. Oh, we already, it's right here too, 1/4. So where was I at? It was minus a 1 times 6 times the 1. It was a 6 times the 1/4 minus 1. All of that mess. 3 times 1 is still 3. 3 minus minus 1 is a 4, and 4 squared is 16. God, I hope this comes out. That's 3 minus 1, or 3 plus 1. That's going to be 4. 4 times 1/4 minus 6 times 1/4. I'm going to call that 3/2. And it was a minus 1 here. I'm taking it slow because the odds I'll make a mistake somewhere. 4 times a 4th is a 1. And minus 3/2. 3/2 minus 2/2 is a half, I think, over the 16. 1 minus a half is a half over 16. So flip the 16 to 1 over 16. I'm going to get 1 over 32, I hope, would be my second derivative. So second derivative at that point, 1 over 32. So that problem took me about 12 minutes. So I beat the 15-minute. Okay. Try to get to an. Let's see. One. These are just more. I like to do a free response. Well, there's another homework problem if you were to have a lecture of those. But these are all review things, so I'm just jumping over to some AP problems. I don't think I'll do this one because it's very similar. It's implicit, and he's just asking for where, this time, well, maybe it is a good one to do. Where is the slope equal to 1/2? That's a good one, maybe. And show where the points on the curve are line tangent are horizontal. Okay, I like those two parts for sure. Yeah, let's do this one. There's no bad problems. Show that the derivative is, okay, we've done one of those before where we just had to prove that the derivative is what they say it is. So I'm going to write out the equation so I have it visible for me most of the time. Y squared equals to 2 plus xy. Doesn't look like a hard one to do. Left to right, I'm going to go 2y dy dx equals 2. The derivative of 2 is 0, so I don't need to worry about that part. But the xy, the product rule. Don't forget, it's a product rule. The first times the derivative of the second, plus the second times the derivative of the first, which was a 1. So now I have dy dx's on both sides. So you're going to have to decide which way you want to move. Which you want to move this over? I probably will do that just because. So 2y dy dx minus an x dy dx equals to a y. Factor out the dy dx, which is what we always do. That leaves a 2y minus x equals to the y. Divide both sides by whatever is next to dy dx, and I get dy dx equals to y over 2y minus x. Is that what he said he got? That is what he said he got. So check. I said I like B. And B says show the points in x comma y on the curve where the lines are tangent to the curve. So I want tangent to the curve are, I wrote the wrong place. Tangent to the curve, I lost track where it was. Find the, there it is. To the curve where the slope is 1/2. So I gotta just take my derivative that I've already done, and I've gotta take that derivative and set it equal to 1/2 and solve it. So the derivative that I've already done was y over 2x, no, sorry, 2y. Minus the x equals to 1/2. And what happens is, to show all points, what you're doing is you're creating an equation that will have a lot of x and y's. So looks like a proportion to me, a fraction equal to a fraction. So I can create it one horizontally by just cross multiplying. That'd be the easiest. 2y will equal to 2y minus x. And this is, you have a choice. You can decide how to solve this. If I solve it for x first, then I can put my y's on one side. So that gives me a 2y minus 2y is a negative x. That can be 0 is a negative x. So x could be 0. That is what would have happened. Now, if x is 0, let's go up to my function again, which was y squared equals to 2y, or no, 2 plus, it was 2 plus xy. So y squared equals to 2 plus xy, and let's use x is 0, because then that will tell me what y will be when x was 0. So that gives me y squared equals to 2. Take the square root both sides, y is plus or minus the square root of 2. So I have a couple ordered pairs. I have 0 square root of 2, and I have 0 negative square root of 2. That will be the two places where the slope is 1/2. C, do I like C? Show that there are no points, that means they don't exist, where the tangent line of the curve is horizontal. Okay. So that's saying, he's not telling you, find all the places where the tangent is horizontal. If that was true, then what you'd be doing is taking that derivative, and you would set for a horizontal tangent, for horizontal tangents, the dy dx basically is 0, which implies, all that really implies is the numerator equal to 0. So I go of the slope. So I go, the numerator of the slope is equal to 0. So since my slope was y over 2y minus x, well, that's just telling me, let me write that out, dy dx, again, was y over 2y minus x. That means only, if I set that whole thing equal to 0, what? If I set that whole thing equal to 0, you can see that the denominator cancels out. So that's why we say y would equal to 0. So if y is equaling to 0, and I plug that into my function, remember what my function again was, I wrote it, y squared plus 2 plus xy. In y squared plus 2, the y squared equals to 2 plus xy. And if I plug in y is 0, I get 0 equals to 2 plus 0. 0 can never equal to 2, so therefore I'm looking for horizontal tangents. I'm not going to find any. It just doesn't exist. So, therefore, there exists no horizontal tangents to the curve. Okay. All right, D. D is let x and y be functions of time, and then and that are related by the equation of y squared. Well, that's my function, duh. At some time t is 5, then the value of y is 3, and dy dx is 6. Find the value of of dx dt. Oh, it's dy dt. Oh, he's doing a related rate thing. Okay, yeah, because he changed it. We're talking about a function of time, but we still have an x and we still have a y, so we still are talking about two functions that are related to this time. So you have x and y in time, so that tells you it's a related rate kind of deal. Wow, it's been a while since we looked at something like that. That ought to be fun. So let's take my original function, d. Wow. Let me write out my equation again. It was y squared equals to 2 minus xy. And I have to differentiate with respect to time. Differentiate with respect to time because it's a related rate. So that's 2y. Remember how we would say y prime? It is y prime, but it's dy dt. Equals to 0 plus or minus. Now no, it was a plus, wasn't it? Go back up and look. Yeah, it's a plus. Plus product rule. Now, when I do the derivative of x, it's a 1 times dx dt. In other words, dx dt. That's the derivative of the first, but I never do the derivative of the first. I just deviated from my normal pattern. I always do the first times the derivative of the second, which is respect to time. So that's dy dt, plus, then I do the second, which is y, then times dx dt. Doesn't matter what order. Some of you do it the other way. That means you just would have these two reversed. It doesn't really matter. So there's my, with respect to time. And did he give me any other information up there? Oh, he gave me a lot. He said x will be 5 and y is going to be 3. Let me write that down there. Let me read the whole thing. Maybe I remember it. And then dy dt will be 6 and dx dt will be 5. So I have 5, 3, 6, 5. Okay. It's a lot of work. It's just a lot of work. It always is a lot of work. He said x will be 5. Well, he didn't say x will be 5, did he? He said time was going to be 5. Yeah, I think that's what he said. Time will be 5. And the value of y will be the 3. And he said that dy dt will be 6. And he says dx dt will be, we don't know. Because we're looking at time is 5. We don't know that. Double check it. Yeah, he said at time 5, the value of y is 3. So in other words, we stop time in 5 seconds or 5 minutes, and we know that's how y is changing. I don't know how x is changing at that moment. So at that moment, at that moment, I will change color, plug in what I know. I know there's a 2 times my y, which is a 3, so that's 2 times a 3. My dy dt, he said, was 6 times a 6 equals to the 2, 3, 6 equals to the x. I didn't see him tell me what x. Let me just write it out for a minute. X. I do know my dy dt. He said that was 6. And y, he gave me the y. He told me the y was a 3. And there's my dx dt that I'm looking for. But you notice I have an x unknown. So that means I need to go and look at my original equation. It was y squared equals to a 2 plus the xy. And then say, well, if my y is a 3, I can find out what that x is going to be. This is called a secondary equation, okay, that I have to use to find this. So 9 equals to 2 times my, no, 2 plus my x that I don't know times my y, which is a 3. Okay, so that's 7 equals to 3x. 7/3 will be the x when, remember, y is 3. So I take that, I can now finish my problem. I can now say 2 times 3 times 6 is 36. 6 times the x that I didn't know a minute ago, 7/3, plus 3 dx dt, which I'm looking for. That's 36 equals to, that's to 14, plus a 3 dx dt. 36 minus 14 is 22, I think. And then I got to divide it by the 3 equals to dx dt. And I'm going to leave it because that's all he was asking for. Wow. This makes me think here. That was A, B, C, D, and it looks like I took a little over 16 minutes. You would probably, in real life, you would be quicker than me because you're not talking to the audience. You're smarter than me, so you won't make those dumb mistakes. You can see better than me, so you don't have to keep looking at the problem, and you have better memory than me. But you know, in reality, if you can't do a part at the end, it's okay. On the old system, this is still only worth 9 points. Even if you say 2, 2, 2, 2, wait, 2, 2, 2, I missed it. I got too many 2s there. 2, 2, 2, 2. 8, one of those has to be 3. And my thinking is this was 3, probably. So you get 6 points that were pretty easy in a little over 10 minutes. I got it in 10 minutes, and I'm going slow. 6 points is good. It's super good, okay? Now, if you look at the sessions being recorded in the evening, I hope you're keeping up, because you will be taking a quiz on the sessions. I will be creating problem sets from the presenters. Whether you're watching them or not, you're taking a quiz. So you should be watching them and learning. All right, so that'll be over the weekend, most likely. I'll put it in this learning, I think. Okay, where am I at? Save what I have and put it up in the cloud, so that way you can watch these today. Thank you. Next. It's a good related problem. Wait, how many minutes did I already spend on these problems? How many did I do? Did I do 3 or 4 AP problems? I'm going to close this lecture then, and